So welcome everybody to Your Technology, Your Way, full stack web and service with .NET and Node. I'm Rob Richardson. Here's the part where I tell you I'm definitely going to post my slides on my site tonight. You're going to go check tonight. You'll check tomorrow. You'll keep hitting refresh in the coming days and weeks. In about 3 months, you're going to get tired of waiting and you're going to email me and I'll promptly reply in 6 months and tell you, no, I'm definitely going to post the slides on my site tonight. Which is why you can go to robrich.org right now and click on presentations. And here's Your Technology, Your Way, full stack with web development, with web and service in .NET and Node. Here's the slides. Here's the code that we'll look at. So here's those slides that we'll look at today. And here's a GitHub repo with all of the content, both the C# examples and the Node examples. They're online right now. So head over to robrich.org, click on presentations, and you'll be able to get at that content right away. Feel free to get ahead. Feel free to heckle me about the slides I haven't said yet. It'll be a lot of fun. While you're here on robrich.org, click on About Me, and you'll get to this page that'll talk about some of the things that I've done. I'm a Microsoft MVP. I'm a friend of Redgate. AZ GiveCamp is wonderful. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp in your area, hit me up on Twitter or email me, and let's see if we can get a GiveCamp there where you can serve your charities as well. Some of the other things that I've done, I do training for Git and Docker and Kubernetes with gitgrit.com. My company is a Microsoft partner, and I lead the Southeast Valley .NET user group. One of the things I'm particularly proud of is I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So that's my claim to fame, is I've gotten to get a .NET Rocks mug. So we're here to talk about your technology, your way. We talked about this guy. So here's the application that we're going to build today. We want to build a full stack mechanism. So we're going to have this web server that is going to host our content. It'll save data into our database, and we'll have a single page application, a SPA, that will hit up that web server using REST calls to get at JSON data. Then we'll also have this service doing stuff in the background. Now the service is going to reach out to the web server via GRPC to know what content it needs to do. This service in theory could reach out to external APIs or do all kinds of things. But for the simplicity of this example, our service will reach out to the web server to say what orders does it need to process. So the SPA will be able to show the orders, allow users to enter new orders, and show the status of those orders. The SPA will call the web server to get the orders. As that order is completed, or as that order is entered, the service will notice that it needs to be completed and will do whatever it needs to complete that order, saving that data back into the database. So everything that we'll see today is free and open source. It's cross-platform. It works on Mac, Linux, and Windows. And it uses web standards. We talked about REST. We talked about JSON. GRPC is also a web standard. And so we'll use all of these web standards in all of the places to be able to get this great architectural platform. So first up, let's dig into what's new in ASP.NET Core 3. Now, what's really cool about C# is you can build anything in C#. You can compile .NET to a desktop application, to a website, send it to cloud content, build mobile apps with Xamarin content. You can build gaming content for Xbox or for other platforms. You can build IoT devices that run on Raspberry Pis. You can build AI models. Anything that you can think of to build, you can build with .NET. And the cool part about .NET, because we can compile to any platform, you can use this single tool chain to do everything. Now, the cool part, because you're building anything with C# and deploying it to all of these things, you can build anything that you'd like to and run it on any platform. .NET itself is open source. It's hosted on GitHub. And so you can go to github.com/.net, DOTNET, and you can see the .NET Core source code. So if you have a problem with something in the framework, you can put in a pull request to get content changed. .NET Core 3.1 has shipped since that gives us an LTS release, a long-term support release. And so all of these features are new in .NET Core 3. We'll see Windows desktop support with both WPF and WinForms. We have full stack development with C# and Razor. We'll see Blazor today. C# 8 shipped in .NET Core 3. We have a worker service template. We'll see that today. And GRPC support, where we can do binary API calls using gRPC over HTTP. So here's that C# app architecture. Here's our same model where we have a front-end SPA, we have an API, and we have a worker service. The front-end SPA will be run by Blazor. It'll make REST calls into our ASP.NET Core Web API. gRPC will run from our worker service to pull data from ASP.NET Core. So let's dig into that experience. If I fire up Visual Studio and I say create a new project, let me find a blank folder. Oh, I'm opening a project. Let me create a new project. Create a new project. If I search for Blazor, I can pick a Blazor app. Now I'm going to pick an ASP.NET Core web application. Here's the way we did it in .NET 3.0. That looks great. In 3.1, they moved it into the front side, but we can see that we have now, let me switch to 3.0. We have two mechanisms of building a Blazor app. Oh, I don't have Blazor in this list. Let me go back the other way. We have two different ways of building a Blazor app. We have a front side in-browser application, and we also have a server-side application. Now, in this case, I'm going to pick a server-side application. This is going to take a second to spin up, but now we see that we have this application. Now it starts with app.razor, and this app.razor is just a Razor file. And so we can see this much like any other Razor file we have, or much like any other Razor page, we have just regular Razor syntax. So I'll have some HTML, I might have some @ things. But what's interesting then about this Blazor app is I have things like this @onClick. Well, when the click event happens, it's going to call this increment count method. Now I have this code section here that shows increment count, and it will do some interesting things. It'll increment this count variable. Now this count variable is bound into place using regular Razor syntax to be able to show some really interesting things. So I'm going to flip back over to the application that we're going to build today. And instead of a server app, this one is a Blazor client-side app. So here's that Blazor client-side app, and it has that counter page, and it has all of the pieces that we expect. Here's that server piece where we can see the a regular web API controller that will go grab those orders. If you ask for orders, it will return all the orders. And if you save a new order, then it'll persist it off to the database. So I'm going to fire this up. And because I have both my client and my server in one project or in one solution, then it's able to compile that into place. Here in my server solution, in startup.cs, not only do I have reference to the ASP.NET content, but I also am using this client-side Blazor, which will run that client startup to be able to kick that content into place. So that's that magic sauce that glues those two pieces together. So I start up my server. and it'll launch the web page. And here's my Blazor app. Now, we talked about I can click this counter button and it'll move, but let me pull up Chrome's Web Developer Tools and let's look at the Network tab. As I'm clicking this, I'm not making any new web requests. All of this is happening client-side. If I go to a different page, still no web requests. All of this is happening client-side. Now, as we first load this page, let's clear this out and refresh the page. We'll see that we're starting to load some interesting things. We load mono.js, we load mono.wasm, and now we start to see that we're pulling down some DLLs. This is just regular .NET code. It just happens to be compiled or running on top of this mono.wasm framework. So my order process.client is right here, order page. Now we see one more web request where we're doing that API to say, go get me the list of orders. Now in this case, there aren't any. So let's create a new order. .NET open source days. I would like one of those. And let's save that order. We can put through another order. I'd like more pizza. We can save that order. Now, each time I'm just doing that web request to save the order, and then doing another web request to get the new list of orders. Those are the only content going back and forth across the wire. This whole application runs client-side in my browser. We talked briefly about the two different types of Blazor apps. Let's dig into that a little bit more. What shipped in .NET Core 3.0 is this server-side Blazor app, where the Blazor components actually run on the server, and there's this small SignalR connection that will connect to this application running in the browser. So at that point, the application, the browser components, all of the rendering, all of that content, all of the processing is run server-side, and the client only has this really thin wrapper around it. This is great for online apps. This is great when you have sensitive information in those DLLs. And that shipped with .NET Core 3.0. Coming in the future, they're going to create a new mechanism where we can have Blazor running in the browser. And that's what we saw just now. We have WebAssembly. Our .NET runtime is running on top of WebAssembly, and our Razor components are running in that .NET runtime, all running inside the browser. These client-side apps are great for offline experiences or places where maybe my server technology isn't the same. So I might choose to run a client-side C# app and hit other APIs. Maybe these APIs are Lambda functions or PayPal APIs. The server side shipped in .NET Core 3. The client side is coming soon. We got to see the client-side preview, and it works great. So if you choose to run the client-side application today, then that completely works as well. So we saw that Blazor and Web API demo, and I love that you can just do that without additional web requests. That works out so well. On the back end, we have the ASP.NET Core 3 REST APIs. Now let's talk about a worker service. Now, typically when we build an app, we'll have that front-end experience, but then we'll also have back-end experiences that need to run longer than a web request. Maybe this is a monthly report or sending emails and retrying them. That back-end service will typically run a Windows service. Here inside .NET Core 3, we have this cross-platform worker service template. Now, this worker service template is really cool. We can create an infinite loop that will run our tasks whenever the loop wakes up. And we can install it as a service in Windows and in Linux, and in Mac, just as easily as we ran Windows services in the past. This is a whole lot lighter weight mechanism of creating that service, that worker service, but it is now cross-platform. So I can go into here and I can, let's close this solution. I can create a new project. this worker service template will create that infinite loop, that initial project. Let's flip back over to our existing project and take a loop at what that looks like. So here's this worker process, and it has a static void main. We create a host builder, but in this case, this host builder is not a web server. This host builder creates a add hosted service of type worker. And this worker class then descends from this background service class. Background service is the .NET Core mechanism for creating these services. And so given this background service, I can use dependency injection in the way that I expect. And then I just have this execute async method. Now this execute async method takes in a cancellation token, and it's my task to then create an infinite loop. So I say, while I'm not stopped, do a bunch of work. I am going to wait 3 seconds between loops. I could do this, however fast or slow I need to, but 3 seconds works in this case. And that just keeps it from, infinitely consuming the resources on the machine. I do want to wait for a little bit. So what am I doing in this case? Well, I'm creating a new channel. I'm using an order manager client, and I'm going to go ask the service for an order request. Now this service is built out using GRPC. Here's this proto definition file, and this is not C#. This is not C. This is a proto definition file. And so this is that industry standard mechanism of doing this. I could get a proto file from a service using any technology, and I could implement it here in C#. So it defines this package namespace. We have this service, and then we have the functions that are running in the service. So get new order takes in a new order request and returns a new order reply. These are just names that I made up. They could be anything. The update order takes an update order request and returns an update order reply. Here's that new order request, the class that I'll take in when I get a new order, and it includes nothing. As the service reaches out and says, hey, are there new orders? It doesn't need to pass in anything, but what it gets back is an order ID. That order ID is an int32, and 1 means it's in the first position of that protocol buffer. Now, the interesting thing is if I want to deprecate a parameter, I just need to remove it from here. And so I can add new parameters, and I don't need to get them out of order. I think protocol buffers are really great in that mechanism. Here's that update order request. I'm going to take in an order ID and a status, and I'll reply with nothing. So this client then, this worker service, will go ask the server over gRPC for a new order request. If it has an order, it will update that order to say that it is processed. Otherwise, it will log out that it has nothing to do. Now on the server end, here on the server, we also have that same proto file, and it is exactly the same as what we expect. And here in the services, we just implement that service. So here's order manager base that will handle each of those methods. So it's going to override the get new order. It's going to override the update order and do whatever tasks we need to accomplish those details. On the client side, we'll just call into that. So if I spin this up, I'll spin up the application again. And then I'm also going to spin up the worker service. Debug. Now here's that worker service. Now it's going to start up. It processed order ID 1. It's going to wait a little bit. It processed order ID 2. So if I come back to my website and I look at my order, another order, let's say order 3, I would like 10 things, and this is a total of 100. Let me save that order. There's that order 3. It's going to pick up that order immediately and process it. And now if I push refresh, I see that that order is processed. All of this is running in C#, and all of this can run cross-platform on any platform. Let me push stop there. So how do I install this service? Well, what's really cool is I come in to this service, let me manage NuGet packages, and I can install various NuGet packages that are appropriate to my hosting environment. So in this case, I installed both the Linux one and the Windows one. And each of those will work on their expected platform, but they will also be a no-op, no execution on any other platform. So here, if I want to use it as a Windows service, I say .use Windows service. If I happen to run this on Linux, it will do nothing. Here, I'm also saying use systemd, so the Linux systemd scheduler service. And on Windows, it will do nothing. And so now this one DLL can be used equally as a Linux service or as a Windows service. So we saw gRPC. gRPC is short for Google Remote Procedure Call. It was originally created by Google. It's now an open source standard. And Microsoft and Google worked together to build this mechanism of using gRPC within .NET. We saw that gRPC and worker service where we could call into our API and do interesting things. We could also call into other services, any gRPC service using any technology, and we'll still get strongly typed results going back and forth. So here's that solution start to finish. We have Blazor running in our browser, running on top of WebAssembly. It's making REST calls to ASP.NET Core. Our worker service is making gRPC calls back to that ASP.NET Core system and ultimately running either as a Linux service or as a Windows service to be able to start up on any platform. We have now all of the tools to be able to build any web technology running on any platform. And the beauty here, there is no JavaScript. All of this was in C#, HTML, and CSS. So that was really cool. Are there any questions about the C# end before we move on to the JavaScript and Node end?
I think I saw a question in chat, like client side works on .NET Core 3.1.
Good question. So Blazor will run on .NET Core 3.0 or .NET Core 3.1, and it will continue running on any version of .NET Core going forward. So .NET 5, Blazor will work just fine there as well.
Yep, I see no more questions, Rob.
Oh, perfect. So that was a lot of fun. We got to see a client-side Blazor app running inside the browser on WebAssembly. We got to see the Windows service running on Windows or on Linux. And all of that was done with no JavaScript at all. Well, what if we wanted to do this in JavaScript and Node? What are our options to do that there? Let's take a look. Well, why would I choose JavaScript? Well, in a similar vein, we want one language that will handle all the things. Now, we've had various experiments of how do we bring our server-side language into the browser, like Flash and Silverlight and Java applets. And each of them have worked okay for a while. But the language of the web is JavaScript. And so the interesting experiment was, well, if we want one language to move across both pieces, what if the server was also JavaScript? So in this case, the server is Node. Now, Node was built on top of Chrome's V8 JavaScript engine. That same V8 engine is the one that powers the JavaScript runtime inside of Chrome's browser and now the new Microsoft Chromium-based Edge browser. That's the same JavaScript runtime. What Node brings to it is you can run it from the command line, and it can read and write files, and it can open WebSockets. Now, in a browser context, we probably don't want to do this. You don't want to run a web server in your browser. You probably also don't want to read and write the file system without users approving mechanisms of crawling outside that sandbox. So from a browser perspective, not having these features is a very important mechanism. but for a server perspective, these are really cool features. So this is kind of fun. I found this tweet and I love this. When we look at Node, we'll often hear people say Node.js or Node.js, or we'll see it written in various ways. I love this guide in kind of helping us understand the culture of what is Node. When Node is written, we don't want to say Node capital J capital S. We don't want to say Node dot capital J capital S. We don't want to just say Node with no .js. The proper way to write Node is Node period JS, where the JS is lowercase. Now, when we speak the word, we don't say node.js. We don't say node.js. We just say node. Now, the interesting thing is, but to be more culturally appropriate, we write it this way and we speak it this way. So you'll see me as I talk about it, even here on this slide, how to say node. There you go. So that's an interesting mechanism of the culture around Node. So Node, similar to NuGet on the C# side, we have NPM, which is kind of short for Node Package Manager, which is also kind of not. They've kind of moved away from the term Node Package Manager and just call it NPM. Now, the cool part, NPM was bought by GitHub not too long ago, and so I'm confident that NPM will be around for a very long time. NPM is a great package manager similar to NuGet, where you can download open source software, and NPM has a great ecosystem of creating small packages that do really interesting things. From each NPM listing, you can click through to the project website, often hosted on GitHub, and take a look at the source code that is in that NPM package. As you pull down an NPM package, you get all of that functionality, and you didn't need to build it at all. Arguably, one of the things that has made Node so successful is this NPM ecosystem of small, lightweight, free packages that do really interesting things. So what can I build with JavaScript? Well, I can build desktop apps through Electron. I can build web apps through Ionic. I can build cloud apps that run in interesting ways using Node. I can build mobile apps using Ionic. I can build gaming content. I can use Johnny 5 to run IoT programs. I can build AI things using things like TensorFlow.js. So all of the platforms that we could possibly deploy to, we could build content with JavaScript. JavaScript and Node runs cross-platform on Mac, Linux, and Windows. It can run on cloud, desktop, IoT, mobile. Node and NPM are open source and hosted on GitHub. So if you want to go check out the source code to how the NPM client works, then you can definitely do that on GitHub. Or if you want to look at the source code for how Node works, you can go to github.com/nodejs/node and take a look at that package. I love this, Jeff Atwood's law. Any application that can be written in JavaScript will eventually be written in JavaScript. And that's a really cool way to think about this. JavaScript is so approachable that we may choose to use JavaScript for those simple tasks and big tasks to do interesting things. So we're going to look at this application architecture, similar mechanism to what we saw in C#. We're going to have a server that hosts APIs. We'll have a client-side SPA, a thick client running in our browser. The thick client will use REST calls to get at our API. And then we'll have a service that will be able to call through GRPC back to our API to get the next order to process and ultimately process it and save those results back to the database. Now, in this case, we're going to choose Vue.js for our client-side framework. We could also choose Angular or React or Svelte or anything. Express is the de facto standard API mechanism. Now, as you choose a SPA framework, Angular, React, and Vue are all great choices. They all are working on the web components data, and that produces interesting things. All three of them will abstract away the Webpack bundler details, so I don't need to worry about how do I get all of these separate files into one JavaScript bundle that I can download to my browser. they'll do that behind the scenes. And they'll also abstract away Babel, the transpiler, that will take ES6 or 7 or 8 or ES 2020 and compile that into a mechanism that works with modern browsers. So ultimately, the choice of whether you choose Angular, React, or Vue, or Svelte, or anything else is a matter of preference. And if you have strong preferences about your technology, then I completely agree that is the right choice for you. So I'm going to choose Vue in this case, not because it's better or worse, but it's because it's the one that I prefer. What I like about Vue, here's an empty directory. I'm going to say Vue create app. Now I've installed the Vue CLI here that gives me this feature. I've done that previously, but I'm going to say manually select features. Would I like Babel? Do I want to enable TypeScript? Would I like to turn on progressive web apps? Do I want a router? Do I want a Flex or Redux like store? Vuex is the Vue's thing. I can turn on CS preprocessors, unit testing, end-to-end testing. It'll kind of interview me and ask me the things that I want. And then for each of those choices, it will ask me more questions about that to further refine its thing. Once it's done, it will scaffold out that entire application, and we won't go through that process because that's a little bit involved. But let's fire up an application that already has this Vue piece in place. Now here's a Vue file. Unlike Angular and React, we have single file components that include our template and our code. But we have these same handlebar-like syntax, the two curly braces, that identify where we want to put our variables in place in our code. So in this component, I'm going to use Axios, a mechanism for using HTTP, to go hit that API. Let me go call out to /API/version, and I'll dump out the information associated with this application. The data, or the language, the runtime, the version, I'll then bind that into this component, and they will show in the page. The API for this is just a regular Express app. And so, for example, here's that API. When I go ask for all the orders, I'll go to the order repository and get all those details and then reply with the JSON associated with that content. As I go to update an order, I'll validate that I have all the things that I want and ultimately add that order into my database, sending back a 201. So let's fire up that API, and we'll also fire up the Angular app, or the Vue app. npm run serve. Now, how does the Vue app know how to connect to the API? I have here in this Vue config file, asking it to proxy anything that starts with /API off to my Express server. And so I'm going to hit this API, localhost 8000. And it starts up my Vue app. Let's go to that about screen where we see that our server is Express. It's running node 12.16.2. As I go to the orders app, I have a similar experience. .NET open source days rocks. .NET open source days is worth so much. It is amazing. And I'm going to save that order. Now that order is pending. There's no worker service running on it yet, but let's add more content, more JavaScript. Now that was great. So now how does that worker service work? Well, the interesting thing about a worker service, it is just a Node app. Node console apps do really interesting things. So if I were to just say npm init, it will walk me through asking about what is my package name, what is my version. I could also do this, npm init-y, and it'll say, okay, here's your thing. And it'll just shoot it all into place. That is perfect. So I did a similar thing here to create my worker service. Here's my worker, it has this index.js that just starts up and does interesting things. Now, similarly, I want to do some gRPC content. So I'm going to go require the gRPC NPM package, and I'll load up that proto file that will show me how that gRPC service works. Now, this proto file is not JavaScript, it's not C, but it specifies the namespace, the method, the class, the method names, their input types and their return types. And we'll be able to see that this is identical to the gRPC proto file that we saw in C#. Now, this cross-platform mechanism then identifies how we'll communicate in this way. So I'm going to say, so once I load up this package definition, I'm going to connect on port 30,051 to that server. I'm going to call my order manager. I'm going to then get a new order, or wire up getting a new order and wire up updating the order. And I'll use Promisify so that I can use async here. And so here's that process order. So if I process an order, I'll go get a new order. If I have an order ID, I'll note that I've processed that, and I'll update it saying that it's processed. And if I don't have an order, then I'll just dump out to the command line. So let's go into that directory and start up the Node API, or the Node service rather. npm run start, and we can see that it will process order ID 1, and then it processes order ID 2, and now no orders are there to be processed. Let's fire this back up. And if we put forth a new order, we can say another order. Let me save that order. Now I'm going to process order ID 3. Let me refresh that order. And now I see that that order is processed. That was great. Let's stop this order processor. We'll also stop the view app, and we can also stop the API. Now, in the same way that I can debug a C# app by doing really interesting things, putting in breakpoints, I can put breakpoints in here as well. So let me put a breakpoint right here as I'm getting the version details, and I will start up my API. Let me start up my View app. The F12 developer tools allow me to dig into the code associated with this app. So I could say here on about, I would like to, oh, it's not going to get me at the, the Webpack details. Nope. Getting out of this into the actual code is interesting, and I would need to modify my JavaScript a little bit to do that. But I now hit that breakpoint. I can see the variables that I have available to me. I can see all their values, and I can push go. In a similar way, let's look at the app, and here in about, I'm going to put in a breakpoint. Debugger. Now, because my Vue compiler is set up to watch these files, it's already rebuilding that content. I'm going to refresh this page, and I get my breakpoint. Now, similarly, I can look at my variables and I can see my data. So I'll put a breakpoint here, and I'll go make that API call. It's going to hit my server, and I can see the breakpoints there. I'll push go. I get back. Here's my response. I see I got a 200. I can look at the headers. I can look at the request. But let's look at that data. And here's the response that I got out of that API. I'm going to close this debugger and I'm going to undo this one and undo this breakpoint. Now we saw the View app be able to do interesting things of binding HTML and JSON. We saw Express, the de facto standard MVC framework for Node, where that binds URLs to functions and allows us to do really interesting things. What's interesting is that there's Sinatra style mechanisms with Sales, but even Sales runs on top of Express. So that's kind of really interesting. We saw how Express was able to handle those APIs in really interesting ways. Then we saw that service using Node app. Now that service could use PM2 to keep that process restarted and running. PM2 can control the number of nodes in the app as well. And at that point, the service is just another Node app. We saw gRPC, how we can communicate between client and server over gRPC and be able to do really interesting things. Are there any questions on the JavaScript side?
So I see a question on Slido. So, but that is specific to Blazor.
Oh, very nice. Let's dig in. What's the question on Blazor?
Yeah, is Blazor an ASP.NET specific thing? Or
Yes.
can standalone libraries be packaged up and used just like JavaScript?
Ooh, very nice. When I run Blazor, I don't need an ASP.NET runtime to do so. It will download that WASM content into the browser. So I can take a Blazor app and I can host it on a static site like GitHub Pages, and the app will work just fine. I don't need to run it inside the ASP.NET runtime. Now that's for a WASM-based client-side Blazor app. If I instead to choose a server-side Blazor app, then I would need an ASP.NET runtime. But the cool part is I can include any .NET Core dependencies there. So I can pull in other libraries. Perhaps I'm going to pull in a Twilio API, or perhaps I'm going to pull in Telerik controls. And all of those work just fine because that's also just .NET Core. And the WebAssembly-based runtime that runs Blazor in the browser is just a .NET Core runtime. Now, if there are features that I need to reach out to do, if it's going to try to p-invoke into Windows, then of course that's not going to work on the WebAssembly version. But that also wouldn't work cross-platform in Linux or on Mac. Perhaps it wouldn't work on Android or iPhone as well. But if I'm using just regular managed C# .NET Core, then that will work just fine with any dependency inside Blazor running on the browser. That was a great question. Thanks for that. Who has the next question? So we saw that we could build with JavaScript using Vue, Express, and PM2. We saw that we could do standard protocols using REST and gRPC, and that we can debug both client and server with Node.NET. It's only JavaScript all the way through, running on any platform, Mac, Linux, or Windows. Well, ultimately, this talk is about your technology, your way. Why would I choose .NET, or why would I choose Node? Or why would I choose Python or Java? You know, ultimately, the goal is for you to empower your developers, to empower yourself to use the technology that makes the most sense to solve the task that you want to solve. So right here in our order processor, as we start up the server, we're going to listen on right here. As we start up the server, we're going to listen on port 50,051 for the gRPC connection, and port 5000 and 5001 for the HTTP connection. Here, we were listening on port 3000 and port 3051. Well, what if instead we listen on port 50,051 for our view, or our PM2 service, and this listens on port 5000 from view. So I'm going to start up our view app. I'll restart that. I'm going to start up our node worker. Actually, let me start up our C# app first. Let's start up our C# server. So here's our Blazor app that's running. Here's our node order processor. And if we start up our view app and we go to about, we see that our server is now our C# server running ASP.NET Core version 3. Flipping over to orders, here are the orders that we put in our C# Blazor app. If I save this order from view, it will get processed using Node, saved back to C#, and I'm able to view my app in view on the client side. Now my Blazor app still works just fine as well. I can go into the orders. I can see that more cross-platform is processed. I'll hit that about page and I'll see the same server details here. But I was able to, because we used web standards, we're able to get completely cross-platform. We have the same REST contract between both sides. We have the same gRPC protocol file that gives us that same gRPC contract. So ultimately, we're able to mix and match our technologies to do really, really interesting things. We can pick the technology that best solves the problem that we're after. We can pick the technology that is the most fun for us to develop in, that will help us best meet the needs of our customers. Ultimately, whether you choose JavaScript or C#, you're able to use all of the pieces in all of the places to do all of the interesting things. Optimize your development process for developer joy and choose the technologies that make you happy. What are your questions?
No questions, Rob.
Oh, marvelous.
Yeah, if there are any questions.
Yep.
Sorry, Rob.
Go ahead.
Yeah, I was just telling, like, if there are any other questions, they can send it over the Slido portal.
Yeah, definitely. And if you find a question later today or tomorrow, reach me on Twitter at rob_rich, or grab these slides at robrich.org and you can contact me from there as well. Definitely grab the code and fork it and continue learning, either with Blazor on the client side or with Vue and Express. Dig into gRPC, the connections between two services, and have a lot of fun. Thanks for joining us today.